Hey everyone! This video is to remind you about what is a systems of equations because it's been a while since we've learned this, and so I wanted to review it with you. You might find this is something you already know, so then you can just go ahead and skip to the next video, but as a reminder, a systems of linear equation is when we use two equations graphed on the same coordinate plane and determine what xy pair will make both equations true. Now, if you forgot what that means, let's just go ahead and start one equation at a time. If I took the equation y equals x plus 1, if I wanted to know what xy pairs would make this equation true, I could make a table. So the way I do that is I think to myself, if x was 0, 0 plus 1 would make y equal 1. And I wrote that here. If x was 1, 1 plus 1 would make y equals 2. I wrote that here. If x is 2, 2 plus 1, y equals 3, and so on. And then I've graphed it over here so you can just see. Sorry about my line that's not very straight, but when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 3, and so on. So that's approximately what that graph would look like. So every ordered pair here is a solution to this equation. Let's take another equation. So here I have y equals 1/2 x plus 3. Now doing the same thing, I always start with 0 in my head. If x were 0, 0 times 1/2 would be 0, and then it would just leave 3, so y would equal 3. If x was 1, 1/2 times 1 would be 1/2, plus 3, that would give us 3.5. I'm switching to decimals here, but it's equivalent. If x were 2, 1/2 times 2, that would be 1, plus 3, y would equal 4. And then here's a graph of that equation just for reference. So what a system of equations is when you have both of these equations together. What xy pair would make both equations true? We can check that by looking at the tables side by side. Although the tables I just made went to 4, and so I extended them so you could see. So this is y equals x plus 1. And here's the table I made, y equals 1/2 x plus 3. So again, these ordered pairs are what makes this equation true. These ordered pairs are what makes this equation true. But we notice that both of them have 4, 5, as in when x is 4, y is 5. And over here, when x is 4, y is 5. That means the ordered pair 4, 5 makes both of these equations true. That is where the systems of equation, the solution is. It's at 4, 5. Now, we did this in class, and you might remember that if you graph it, that's where it intersects. So let me adjust my papers here. Online learning is difficult. We can also see the solution when we graph both equations on the same plane, because the solution is where the two lines intersect. So here is the y equals 1/2 x plus 3, and the y equals x plus 1. And I just drew this out by hand. So you can see this is by ones, this goes to 10, this goes to 10, this is y, and this is x. So the solution here is when x is 4, y is 5, that's when they lines intersect, just like we saw in the tables. You might be thinking to yourself, what if they never cross, or what if it's the same line? And if you recall, back when we learned this in class, in your textbook, which is on page 258, by the way, this is 5-1, we know there are 3 types of solutions in a linear system. The one we're going to focus on today is when they cross one time right here. And then we have also when they never cross, which is, if you'll notice, same slope but different y-intercept. And then again, when they have the same line.